Let's do another example using regression. So we're going to do B. As a science project, Shelley is studying the relationship of car mileage in miles per gallon and the speed in miles per hour. The table shows the data Shelley gathered using her family's vehicle. Using a graphing calculator to create a scatter plot of the data, find a linear regression model and graph the model. Then use the model to predict the gas mileage of the car at a speed of 20 miles per hour. All right, so first of all, we have to look at the problem and determine our dependent and independent variables. So does speed depend on mileage, or does mileage depend on speed? If you said that mileage depends on speed, you are correct. So remember, x is our independent variable, which in this case would be the car's speed, and y is our dependent variable, which would be the car's gas mileage. Okay. Now, the second question, what viewing window will you use? I don't like to really change viewing windows because it is a lot of work, and I will show you guys how to do that, right? And we use the scatter plot, which automatically zooms it in on our statistics, but you still need to know how to change our viewing windows, okay? The easiest way we can do this is identify the x values, which we will be using, and the y values that we are looking at, okay? And the easiest thing to do is start at 0, really, for these. So looking at our x values, the car speed, we can see that we range from a speed of 30 to 70 miles. Well, I'm going to make my window from 0 to 80, okay? For the y values, we're talking about mileage. I'm also going to start it at 0 just to expand our window a little bit. And looking at the mileage, we can see that we go from 27.5 to 34. So I'm going to expand that just a little bit up to 40. Okay. Now, let's go ahead and look at this using our graphing calculators, and I'll walk you through the entire process. Okay, let's go ahead and enter the data for the speed and mileage. As a reminder, stat, edit. This gets us to our list, and you can see that I still have the information in there from example A. Scroll up, hit the clear button, and you can see that it erases all the data, and press enter. Do the same for both and start over fresh, okay? Now we are entering our data. I'm gonna start with speed. Remember, we said speed is x, so we're gonna enter the x values. Now our table is horizontal, so be cautious when you enter it, left to right. Remember to keep them lined up with the y values. So we have 30. Trying my best here to hold my calculator up. 40, 50, 60, and 70. Okay. For the mileage, you can see that 34 lines up with 30, 33.5 lines up with 40, 31.5 lines up with 50, 29, and 27.5 lines up with 70. Okay, now to see it as a graph, remember we go zoom and scroll. You can either scroll down or you could just press the number 9 and that'll take you to the zoom stat. Okay, very easy. We see our scatter plot here. Now, we also talked about how to manipulate our window range down here. It asks us to change the window. So the way we do that is you are going to click on the button that says window, and you can see you have x minimum, x maximum, y minimum, y maximum. Those are the values we are going to change. So we had previously said we were going to use 0 to 80 for x. So our x minimum is 0, our x maximum is 80. Our y minimum, we said, was 0. Our y maximum was 40. Oops. And then we're just going to hit the graph button, and that'll change your viewing window, okay? Now, this line that is appearing here, remember example 1, we typed it in. You can always just go back and clear, and then hit graph, and that's just focused on our stats, okay? our stats referring to the table of data that we just entered. Based on what we just saw in the calculator and what we talked about, the trend we observed, so we can say the trend appears to be linear with y values decreasing as x values increase. And that's exactly what we saw in our calculator. Now we are going to model with regression. Okay, so first of all, let's go back to our calculators and determine what our regression model is. To calculate regression, remember we hit the stat button, calculate, and linear regression. Okay, we have our equation, y equals ax plus b. A equals negative 0.175, b is 39.85, and r, the correlation coefficient, is negative 0.98289, all of these, okay? Now, for consistency, from now on, for your assignments, I want you guys to round to the thousandths place, so 3 decimal places. We're going to leave a as it is. B does not have a thousand, so we leave it as it is. Correlation coefficient, you're going to round it to negative 0.983. Okay, write those down. Looking at our regression values, you should have y equals negative 0.175x plus 39.85. And our domain values, remember the domain comes off of the minimum and maximum of our data. So if I go back, minimum is 30, maximum is 70. So the domain lies from 30 to 70. Okay, now graph this line and let's talk about the line of fit. Once you have written them down, come over to your graph, okay, and we're going to type it in. So y equals negative 0.175x plus 39.85. Graph it. And what can we say about the goodness of fit? Now, I know goodness of fit doesn't sound right. It is also known as the line of best fit, if you guys have heard that before. And as you can see, this line crosses through 2 points and it touches the other 3 points. It is a very, very close. Finally, you are asked to make a prediction for the gas mileage of the car at a speed of 20 miles per hour. Now, how do we make a prediction? We can take our equation and we can substitute in for x. So I'm going to say x equals 20, and I'm going to plug it into our regression model. Negative 0.175 times 20 plus 39.85. So plug that into your calculator. And you should have a value of about 36.4. Okay, so what this model is telling me, okay, my prediction is that the car's gas mileage should be about 36.4 miles per gallon at a speed of 20 miles per hour. Finally, the reflection question, I wanted us to look at the differences between interpolation and extrapolation. So remember, based on the definitions, interpolation is a prediction made within the domain. Extrapolation is a prediction made outside of the domain. Looking at example A, we made a prediction of 150. The domain went from 110 up to 188. So would example A be interpolation or extrapolation? If you said interpolation, you are correct. Interpolation, okay? How do we know? Because 150 is inside of the domain. For example B, we made a prediction of, or using a speed of 20, when the domain ranges from 30 to 70. 20 does not fit the inequality. So for example B, we used extrapolation. Okay, how do we know? Again, 20 is outside of the domain. All right, so we did A and B together. Go ahead and try C. You're going to run through the whole process, determine your independent and dependent variables, graph them into a scatter plot, find your linear regression model, and then graph your regression model to describe the fit. Go ahead and press pause and then come back when you have your answer. Okay, let's talk about this. First of all, you should have determined that days was your independent variable and Y was your dependent variable, which is the number of hits. Okay, so plugged it into your calculator. Top row was list 1, bottom row was list 2. After plotting it, you can see that the scatter plot appears to be somewhat linear, meaning we could draw a straight line somewhere through it, and most of the points would be centered around it. Performing regression, your A value was 2.409, your B value was 11.22, and your correlation coefficient was 0.794. Based on this value alone, you know that your regression model will be an okay fit, meaning that it will be loosely centered around the points, just as we described up here. Okay, now your prediction, plug in 15 into the equation, and you get a total of 47. So our prediction says on day 15, there will be 47 hits, okay? And I know it did not ask you this, but based on the domain, which we did not identify, your domain should be from 1 up to and including 14, okay? Based on the domain, we know that this is an extrapolation prediction. 15 does lie outside of the domain values.